Hello, my name is Lorenzo Buda, and this is Lab 2. This is a 3.1 with the gate or structural implementation. I have a 4-bit wire named A. I have my input E, which is my select, because we're trying to do a 4 to 1 decoder. And then I have my output, which is 16 bits, and it's my Y. So these are my assignments based on the gate implementation of a 4 to 16 decoder where um I've always check if my select my E is 1. If not, any of these are gonna be any of my outputs are gonna be 0, and then it's gonna be a mixture of my input wires A3 through 0. Either they're knotted, it's gonna be like not A3 or whatever input A through 0, or it's gonna have just a regular A without being not. This is the XDC file where I am only using 5 ports. The first 4 pins, right? For A through A0 through 3, and then E for my select. And then I have all 16 LEDs. And then this is my test bench where I set up my switches, my select, my light, my test bench right here. Initial, begin, so it just keeps going. It starts the testing. I do my select at 1. I check all of my inputs from 0, right? 0, 1, 2, 3, all the way down to uh, just all 4 bits being 1. And then I change my select to being 0. And then I just do a couple test cases uh, of changing my inputs, and then I finish it. This is my simulation profile right here. So you have, see my value is 0 for my input, and my first one, light 1 is on, right? My first bit is on for the light, and then I change it to 1, right? To my select in this at this moment is always 1. So, and you can see that the light is changing here. See, so number 3 is changing. Let me go back to here, right? Input 4, you can see that my select, you can see that this select is changing, is actually going up with the value. And then I go here after this, it's F, it reaches the final light of LED number 16 or LED 15, depending on, because it's 0 through 15. And then after that, my select is 0, and then no matter what value I input, the output is always going to be 0. That's one simulation. That's for the gate or structural implementation. And I have another one here. Let me stop this one. Let me close this simulation. And let me start running this one. This one has the same exact XDC and the same exact test bench. The only thing that changed is now, instead of, this is a behavioral, so it's just a case value, kind of like if else statements, if you're writing in like C or C++, where it's always gonna be, it's gonna check if my select is 1, right? If my E is 1, then it's gonna check case my A, which is my wire. My output Y is gonna be a register, and then it's checking, hey, if it's all zeros, you light up this, right? You have this 16-bit value of Y, you light up the first bit, and just goes down the line. So if I were to run the behavioral simulation for this one, uh, make this bigger and open it up, we can see that it has the same exact running. It has the same exact values. 0, right? The first LED is on, then the second, the third, and it just keeps going up based on our input. And then if our select is 0, our lights are all off. Also, another thing to note is that we had 8 when we ran the synthesis, we had 8 LUTs, but all 21 ports were used. 4 for the switches, 1 for our select, and then 16 for our outputs, and that's going to be shown in screenshots um in our report. I ran the simulation and the synthesis simulation, and then just ran the synthesis to kind of double check both of the LUT values were the same for both. But Len, my lab partner, is also gonna show the physical implementation on the board, and he ran both the synthesis and the implementation. So he actually coded the hardware. Uh, I'm gonna send that off to him now.
Hi, I'm Len. I'll be doing the demo. This is going to be our enable switch. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, no, 15. This will showcase that our enable is off, so I flip these, doesn't do anything. But if I turn it on, then now they go where now it works.